Hello guys, in today's video I am going to solve 15 organic problems from aromatic hydrocarbons. I am Dr. Rami Khan and I was an ex-faculty of Akash in Mumbai. Without wasting more time, let me start the questions. So the first question is, among the following, the wrong statement is. We need to identify, or we need to choose the wrong statement. Okay, the first one is aromatic hydrocarbons are the derivatives of benzene. This may be correct, but there are many aromatic compounds which are not derivative of benzene, so this is wrong. Let's just check other options also. Benzene contains 9 sigma and the 9 pi bonds. Benzene contains 9 sigma and 9 pi bonds. Okay, aromatic hydrocarbons. Okay, let me draw benzene. This is our benzene, and to each carbon atom there are has one hydrogen atom attached. So number of sigma bonds will be 1 2 3 4 5 6 7 8 9 10 11 and 12. So this is wrong. This is not correct. This cannot be correct. This can be correct, or this cannot be correct in fact. But pyridine is there, right? Or pyrrole is there. They are also aromatic. They are not hydrocarbons, sorry. Means there may be other hydrocarbons which may be, right, which may not be the derivative of benzene. Let me give one example. According to the question, this is the correct answer, right? This cannot be correct because benzene contains 12 sigma bonds and 3 pi bonds, right? So here it is given 9 sigma bonds only, so this cannot be correct, right? And the third option is aromaticity of benzene is due to delocalization of pi electrons. This is correct. All carbon atoms in benzene ring are involved in sp2 hybridization. This is also correct. So the most incorrect statement is 2. One may be correct or incorrect because see, this is a hydrocarbon, right? This is a hydrocarbon, and this is not a derivative of benzene ring, right? But this hydrocarbon is aromatic, right? This is not a derivative of benzene ring. So there are many derivatives of benzene which are aromatic, but not always. But according to the question, this can be the answer. This must be the answer. Okay, let me go to the question. Next question is, the carbon-carbon bond in benzene is less than in ethylene. This is ethylene, ethene is ethylene, and acetylene is this one, right? This is acetylene, and ethane is this one, right? This is ethane. Okay, so bond length is inversely proportional to bond order. Here it is bond order is 1, it is bond order 2, and in acetylene this is bond order 3. So in benzene, what will be the bond order? This is the question. In benzene, bond order is 1.5, not 2, not 1. So this must be in between. This must be in between this. Okay, so this must be, this is bond order, right? And for bond length, this must be first in bond length, this must be second, this must be third, and this must be fourth, right? So this is third. So bond length of benzene must be less than that of acetylene. So this is the correct answer. Okay, this is acetylene. So let me go to the third question. The third question is, which of the following is represented incorrectly? Okay, this is benzene and reacted with chlorine in presence of sunlight. AlCl3. So C6H6 C12, though this is not C, actually this is a printing mistake. This must be Cl, right? Cl6. So this is correct. This is not correct option. We need to choose the incorrect reaction, right? Benzene reacted with methyl chloride and toluene is formed plus ICl is an example of Redl-Crafts reaction. This is also correct. Distillation of phenol with zinc dust gives benzene. This is also correct. Benzene reacts with acyl chloride in presence of AlCl3 to give C6H5COCl. This is not correct. Okay, this is not correct because we need to form acetobenzene. Let me write. This is the correct answer for the question. Okay, let me write the correct reaction. This is our benzene, and if it is reacted with ClC double bond OCH3, this is acetyl chloride in presence of AlCl3. This is Redl-Crafts acylation, right? So hydrogen will go out and we will get this acetobenzene. So the answer must be C6H5COCH3, but it is not the correct option given here. This is benzoyl chloride is given. Okay, so acetophenone must be the answer. So the incorrect reaction among the given options is the fourth one. Okay, this is the incorrect option, means this is the incorrect reaction, so the correct option is 4. Okay, let me go to the fourth question. The fourth question is, in the reaction phenol reacts with zinc distillation, A is formed, A, and on reacting with concentrated H2SO4 then present concentrated HNO3, B is formed. So A and B are okay. Let me write this phenol. This is our phenol, and if phenol is reacted with what, zinc dust and heated, distillation means heated, then zinc oxide will go out and we will get benzene. So A must be benzene, right? This is our A. And if it is reacted with concentrated HNO3, this is nitration of benzene, very easy reaction, in presence of concentrated H2SO4, and it must be heated, and we will get nitrobenzene. This is our nitrobenzene, right? So nitrobenzene, this is nitrobenzene. Okay, so this must be our B. So benzene and the nitrobenzene must be the correct answer. Benzene aniline, no. Benzene sulfonacid, no. Benzene nitrobenzene, this is the correct answer. 3 is the correct answer. Okay, let me go to the fifth question. I'm going to solve 15 questions, so without wasting time, the fifth question is, among the following compounds the decreasing order of reactivity towards electrophilic substitution is. Okay, the reactivity of electrophilic substitution reaction increases by electron donating group and decreases by electron withdrawing group, right? So methyl is an electron donating group due to inductive effect and hyperconjugation. Methoxy group is an electron donating group due to resonance, and the resonance is more powerful than hyperconjugation and inductive effect, so this must be most reactive. And CF3, due to minus I effect, this will be a deactivating group. So the first one in the reactivity series will be third, then comes 1, then must come 2, and then 4th. This will decrease the reactivity of electrophilic substitution reaction, because this is a deactivating group, electron withdrawing group. So 3 1 2 4, 3 1 3 1 2 4, the first option is the correct option, right? Okay, let me go to the next question. The compound, this is a compound where it is given that X is an orthopara directing group. This is an orthopara directing group. Okay, and Y is a meta directing group, and we know that meta directing group is a deactivating group and orthopara directing group is an activating group. except halogen, right? But halogen and this is halogen, for example, and meta directing group is, for example, NO2. So this is weak deactivating group, and NO2 will be a strong deactivating group. So among the deactivating groups, halogen will be the least deactivating group, right? So the product will be according to this Cl. If X is what? Halogen. And if X is not halogen, then they are all activating groups, right? So the product must be according to X, not according to Y. So, and since X is an orthopara directing group, the electrophile will come to this position or this position, right? So let me choose. Electrophile may come here also, but due to static hindrance, that will be less preferred. So this cannot be the answer. Z. Okay, we are going to introduce Z. Okay, this is the correct answer. Let me choose the third one also. Let me check the third one also. Third one is also correct. The question is not about the major product. The question is about the the compound that can be formed when an electrophile Z is introduced to this reactant. Okay, so 2 and 3 may be correct because option 4 is given both 2 and 3. So the correct option will be 4, not 2 or 3. This is a combination of 2 and 3 because X is an orthopara directing group, and orthopara directing groups are generally what? Activating groups, except halogens. Okay, now let me go to the next question. This is a good question. The next question is the molecular formula of diphenylmethane C13H12 is. This is the molecular formula of diphenylmethane, and the question is how many structural isomers are possible when one of the hydrogen is replaced by chlorine atoms. So in this question we need to check how many different carbon atoms are present through which substitution by chlorine can take place, right? So this is one of the possibilities. So one possibility is the substitution of this hydrogen by chlorine atoms, and then we need to check whether is it possible to displace hydrogen from here or not. The answer is no, because there is no hydrogen to this carbon atom. Okay, there is hydrogen to this carbon atom, but this carbon, this carbon, this carbon, this carbon, they are all equal. So 2, right, 1, this is 1, suppose, and these are second possibility of monochlorination, and third possibility is here, and here. So these are third possibilities, right? So, and fourth possibility is to this carbon atom. So we will get 4 monochloro products here. So the correct option will be second one, 4. Okay, right. Let me go to the next question. 8th question. Okay, the conversion, this is n-propyl benzene to para-bromo and propyl benzene, okay, can be affected using, this is ring substitution, electrophilic substitution reaction, and bromination. And bromination takes place in presence of Br2, not with CCl4, not with water. Iron may be correct. Br2 not with benzoyl chloride. Okay, so this is the answer, because bromination, electrophilic substitution by bromine may take place in presence of Br2 in Br and Fe, or I can say FeBr3 also here, but there is not that option. So the correct option is Br2 in absence of light. Okay, which of the following next question, which of the following is expected to be aromatic? We need to choose the aromatic option from this 4. Okay, to check aromaticity we need to check hybridization of each carbon atom in the benzene in the ring, in the cyclic ring. And if the hybridization is only sp2, then this may give aromatic or anti-aromatic, right? And if one of the atoms in the ring is sp3 hybridized, then the compound will be non-aromatic, right? This is the approach. Okay, now first of all, let me check the first option. This is sp2 sp3, this is sp3 hybridized, right? So this cannot be aromatic, this is non-aromatic, right? This is non-aromatic. What about this second one? This is sp2, this is sp2 sp2 sp2. Okay, this can be correct. Okay, this can be correct. And what about this? sp2 sp2 sp2, this is sp3 hybridized, this is sp3 hybridized, so this compound is also non-aromatic, so this cannot be the option, this cannot be the option. What about this? sp2 sp2 sp2, this carbocation is always sp2 hybridized, remember, carbocations are always sp2 hybridized, right? So this can also be the correct answer. Now the answer is fourth one, this is aromatic, while this compound is anti-aromatic. Let me give the approach for that. If that hybridization of each atom in the ring is sp2, then we need to count number of pi electrons in the ring. So there are 1 2 3 4 4 pi electrons are here, and in this 1 2 3 4 5 6 pi electrons are here. Okay, so we will equate the number of pi electrons, 4n is equal to 4 in the second option, and we will get n is equal to 1 in this case. So this is the condition for aromaticity, sorry, anti-aromaticity. And here 6 will be equated to 4n plus 2 is equal to 6. That will give a value of n is equal to 1. This is the condition for aromaticity. This is nothing but Haeckel's rule. So according to Haeckel's rule, this will be aromatic, while this compound will be anti-aromatic. So correct option according to the given options will be fourth one. This will be aromatic. This is anti-aromatic. American misalnya anti-aromatic kind. Okay, we are giving the pronunciation as anti-aromatic. These two are 1 and 3 are non-aromatic. Second one is anti-aromatic, and the fourth one will be aromatic, and this will be our correct option. Okay, let me get to the 10th question. The measured product obtained in the reaction, this is the reaction, and we need to choose the measured product here. Okay, we need to choose the measured product only, the product which is formed in large amount. Okay, now 2 benzene rings are here, and one of them is attached to CO carbonyl group, which is a deactivating group, right? Carbonyl is a deactivating group. Okay, and this is CH2, this is an alkyl group, and alkyl group is an activating group. So in electrophilic substitution reaction, remember we must give the product according to the activating group, because electrophile will prefer that benzene ring which have excess of electron. So this CO will deactivate this benzene ring, while this CH2 will activate this benzene ring. This will provide electrons to this benzene ring due to hyperconjugation and inductive effect, while this CO will deactivate this left hand benzene ring due to minus R effect. This will give minus R effect, and this will give electrons to this benzene ring with the help of hyperconjugation or inductive effect. That will be plus I. Okay, so this CH2 is an orthopara directing group, and remember between ortho and para directing group, para isomer is the major product, and if there is no intramolecular hydrogen bonding. Okay, so this is not a correct option because CO is meta directing group, and we must not keep the major product for the meta isomer. Okay, so this is the correct option because CH2 is an ortho para directing group, and para isomer is the major product. Okay, we need to give only one mole here. Okay, so this cannot be, this can also be the correct option, but this is a meta directing group, but it is not said in the question that we need to provide 2 moles of bromine. Okay, so we need to keep this option as the correct option, and if it is given 2 bromine, then we may consider other option also, but according to the question, this is the correct option. This is the major product. Okay, the 11th question, the final product obtained in the following reaction. This is the reaction, and we need to give the final product. Okay, this is Friedel-Crafts acylation. Benzene is reacted with propanoyl chloride in presence of LCl3. So let me write the reaction here. This is our benzene, and if it is reacted with CH3, CH2, CH2Cl, no, oh, sorry, this is wrong. This has to be CH3, CH2, COCl, right, in presence of what? AlCl3. So this is Friedel-Crafts acylation, so we are going to get this as the measure, this as the structure of X. This is our X, right? Now with this X we are going to react with methylamine, and methylamine and this ketone will react to give a Schiff's base. So let me write here, and if it is reacted with methylamine, we are going to get this product. Let me write here. Okay, C double bond N, and to this N methyl group will be attached, and ethyl is attached here, right? And to this compound we need to add hydrogen in presence of nickel, and that is, this must be reacted again with hydrogen, catalytic reduction. So this carbon and the nitrogen will be reduced to CHNS2, and if it is reacted with hydrogen in presence of nickel, we are going to get, not this one, this second product. Okay, this will be the product, right? So correct option will be second one. Okay, let me go to the next question. This was 11th question. Okay, this is 12th question. In a set of reactions, ethyl benzene yield a product Y. Sorry, D. So we need to identify D would be. Okay. Okay, now let me write the reaction here. This is our ethyl benzene, and ethyl benzene is reacted with KMnO4 in presence of a base, alkaline KMnO4. So we know that this alkyl group will be oxidized to carboxylic group, right? This is our B, this is our B, and if it is toluene also, we will get B, benzoic acid only. Okay, and if it is reacted with Br2 in presence of FeCl3 or FeBr3 or Fe, bromination will take place, and we know that this COOH is a meta directing group, so we are going to add bromine at the meta position, and this C is reacted with what? ethanol in presence of an acid. Then this is esterification reaction. Carboxylic acid and alcohol will get an ester. So the product will be C double bond O, and to this carbonyl or to this CO, O will be there, and the 2O, this OC2H5 will be attached. C2H5 will be attached. This is an ester, and bromine will be there. This will be our D. This was our C. Okay. So this is the structure of D, and the correct option is fourth one. Okay, this is the correct option. Okay, let me go to the next question. The next question is, which of the following groups would enhance the reactivity of electrophilic aromatic substitution? Okay, so will enhance, we need to choose the option that will enhance the reactivity of electrophilic substitution reaction. Means we need to give the electron donating group as the correct option. Okay, CN is a deactivating group. No, CHO is also deactivating group. CH3 is the answer. This is a deactivating group. So let me go to the next question. This is the correct option. Okay, which of the following will be obtained by the bromination of ethyl benzene in presence of light? In presence of light. Okay, so this is ring substitution. In presence of light, no ring substitution takes place. Okay, so this cannot be the answer. This is also ring substitution, not the correct option. This is the correct option, because according to the reaction this can also be the answer, but since we need to choose only one product, we need to choose the major product. So benzyl substitution will be our major product. So this is the correct option. Okay, let me go to the next and the last question of this video. Which xylene is most readily nitrated? So xylene means the benzene ring we need to attach to methyl group, that is called xylene. Okay, in orthoxylene we need to attach methyl to the this 1,2 position, and in paraxylene we need to attach methyl here and here, right? And in metaxylene we need to attach one methyl here and one methyl here. Okay, now we need to do nitration, right? This is orthopara directing group. Orthopara, right? Orthopara. This is ortho, this is ortho, this is ortho, this is ortho. We need to choose. See, such questions are very good questions, and we need to choose that correct option in which two, this arrow comes, right? So no two arrow coincides in these two positions, and in this case, see, this is an orthopara directing group. Methyl is an orthopara directing group. This is its position, but here substitution will take place in less amount because of steric hindrance, right? So this is its position, this is its position, right, for this methyl, and for this methyl this is its position, this is its position, and this is its position. So two arrow coincides, right? So into the ortho position of this methyl or to the ortho position of this methyl, they will be same. So this will be the most reactive. Metaxylene will be most reactive in nitration, or most readily nitrated. So the correct option will be metaxylene. Okay, let me complete this video here, and please share this video if you like to your friends, and if you are new to the channel, also subscribe to the channel and press the notification button, so that whenever I upload a video you get it immediately. Thank you.